Greetings once again. Welcome to another edition. In this session, we are going to be looking at polar curves, specifically Limacons. And under Limacons, there's many types of curves which you will find. The one which we'll be looking at in this video will be the cardioid. So as many of you know, whenever you are speaking about the cardioid, something comes to mind. What comes to your mind is obviously the heart. That is what you think of when you think of a cardioid. And for different people, they draw the heart differently. Others would draw their heart this way, and others would make it to be more, a bit soft and heavy. Others would make it sharp. But the point is that when we think of cardioid, what we think of is the heart. So the kind of heart which we'll be looking at for these graphs is a heart that looks more like this. That is the mathematical, or that is the graph which we are going to draw from the mathematics which we will be looking at. So essentially, you can go now and smile. You will be able to do, at least at the end of the session, to give an equation, and that equation will amount to a heart at the end of the day when you do the sketch. So there's two types of equations which we are going to look at. For our cardioid, which is still a Limacon. So the first equation we are going to look at is R equals A plus or minus B cos of theta. So what we should know is that whenever we see cos of theta, what we should be thinking of is HA. So cos is associated with the horizontal axis. That is the first thing that should come to our mind. And whenever we see R equals A plus or minus B sine theta, what should come to our mind is VA. What is VA for? Sine, if you remember, according to our polar coordinates, is associated with y, of which y is a parameter that describes the vertical axis. So these are the two equations which we are going to be looking at. But the question which we need to ask ourselves is, what makes a cardioid? What is the condition which we require? So the condition is for us to consider an expression to be a cardioid, or the graph which we are going to get. For it to be a heart, what we require is that our A divided by B should give us 1. That is the condition which we require in order for us to find a cardioid. A divided by B should give us 1, which means if it doesn't give us 1, your shape will not be a heart. So this is required for the shape to be a heart. We require A divided by B to be equal to 1. And just one important thing which I need you to note is that the A and the B are just numbers. So they are independent of the sign. So the plus or minus sign will sit in between them. But the A and the B, we want them to be positive. So how this will work is A will be positive and B will be positive at all times. These will always be positive. It is just the sign in between them that can change, but always look at the actual number. Okay. I plead with you that you always do such. As long as A divided by B gives us 1, it means that we will have our cardioid. And our cardioid will just be our heart that looks like this. This here is our cardioid. So because we know that we are dealing with horizontal and vertical, it means we will expect some of the cardioid shapes to be something like this. Some of them will be something like this, and then others, will face the other direction depending on the signs, as you will see. Well, that does not look good at all. So there's many types which we'll be looking at. So let's go ahead and start exploring these cardioids. Okay. So one thing I need to remind you is that a plus, obviously, when we look at the signs, when we have a plus, it means that the cardioid is to the right. And when we have a minus, it means the cardioid is to the left. And when we look at the other one, which is the sign, remember sign has to do with up and down. If we have a plus, it means the cardioid is leaning upwards. If we have a minus, it means it is leaning more downwards. So let's go and explore what these mean and how we can apply what we are learning to be able to plot these graphs. So we are going to be looking at R equals A plus B first, cos of theta. And remember, we're looking at the cardioid. So what that means is that our A divided by B is 1. This will apply only if A divided by B is 1. So how does it work? We start at the origin like that. So we start there at the origin, we go around and around, and then we come back there at the origin. If you look carefully, that looks like our heart, which is our cardioid. Okay? It shouldn't look skewed as it does. Let me fix it. So that is our cardioid. Now what we need to ask ourselves is, how do we then find the points which we have here? And if you think carefully of this cardioid, this would be the cardioid which we get whenever we have a plus. So when we have a plus, it faces to the right-hand side. So it leans to the right-hand side when we have a plus before the B, which multiplies the cos. So the points of interest are the points there, and also the point which we have there. So the point which we always have there at the top will be point A, and the one we have here at the bottom will be A. The one that we always have there will always be A plus B. So remember that B is just a positive number and A is also a positive number. Okay, that is how we get those points. Now let's have a look at the next one, where our R becomes A minus B cos of theta. Okay, so because of the negative here, and we know that we are dealing with cos, and cos is associated with the horizontal axis. So it means our cardioid, Limacon, should lean more to the left because of that negative sign. So we are going to go and draw it something like that. It goes back there. That is our Limason. It is leaning towards the left because of the sign here. That is the sign that is making it to face left. Okay. And on the other side, that is the sign that is making it to face right. Because it's a course, we are dealing with it shifting, horizontally, either facing the right or the left. And there's 3 points we're interested in. It is this one, and this point will always be given by A, and that will always be given by A. The one which we have here will always be given by A plus B. Okay, that is how we find the points. So this is the type of Limason or cardioid which you find whenever you are dealing with cosine. Remember, cosine has to do with the horizontal axis. So let's go to the sine one. So let's assume we are given R equals A plus B sine of theta. And remember, we are dealing with the cardioid, meaning our A divided by B must be 0. That is the only time where we are going to plot the graph this way. Okay. Because of this positive, which we have here, and we know that for sine we are dealing with up and down, it means that I'm supposed to plot my cardioid in that direction, going up. So what we are going to do is we are going to do our cardioid like that. Okay. And then we need to go and figure out what these points are. So this point here and that point there, wherever it crosses, this will always be given by A and A. The top point there will always be given by A plus B, whatever the value of A is and whatever the value of B is. Okay? This is very important. Okay, now let's go to the next one where we are given R equals A minus B sine of theta. So remember here, B is still positive. It doesn't mean that B is negative in any way here. So I need you to keep that in mind, that B is positive. Okay, so let's go now. So if you look carefully, we have a negative before B. So what that means for us is that we will have a Limason, because we have sine, it will be pointing down. So if we go and draw it, you will see that our Limason will look something like this, like that. Okay, it must be heartish when you look at it. And then this point here will always be given by A, and that point will always be given by A. Then the one which is on the far will always be given by A plus B. That is how we draw our Limason, which for this case, we are specifically looking at the cardioid kind of Limason. So this is the information which you need for you to be able to go and plot all the different Limasons which you will come across. From here, we will go and look at a couple of examples where we will exercise and see if we understand cardioid Limasons. Hopefully, you will be able to apply this knowledge. Let us have a look at example 5 to try and apply what we have learned on this page. So example 5 reads, sketch roughly the curve described by the polar equation below. And the polar equation we are given is 2 plus 2 cos of theta. So the first thing which we always need to outline, you will see in subsequent sessions, is the value of A. So the value of A is 2. The value of B is 2. Remember, I'm not looking at that sign as of yet. And if you remember, we always need to do A divided by B, which will give us 1. So once we know that A divided by B equals 1, we should know that what we are working with is a cardioid. Okay, so what does cardioid mean? It means that we have a shape that will want to be heart-like, like this. Okay, that is the kind of shape which we are going to have. It will be heart-like. And then the positive sign tells us if we should be leaning towards the right or towards the left. So remember, we are working with cosine. So with cosine, this means that we are looking at the HA, which is the horizontal axis. So we need to decide, are we leaning right or left? And because of the plus there, we are going to be leaning right. Okay, so let's go and put in our cardioid. So our cardioid will start at the origin. It will go up, move, and then come back there. Okay, that is how our cardioid is gonna look. Then we need 3 points. We need that point and that point and that point there. And if you remember, this point up here, we've always said that it is equal to A, and our A is 2. So even that one is equal to A, which A is 2. And then the point which is there, we've always said it is A plus B, which will give us a 4. So essentially, I can just erase these or maybe leave them as they are. And this is how our sketch will look. So we have a 2, and a 4. That is how our cardio will look. Okay, for this example, I hope this makes sense and you understand how we came about to have a cardioid which looks like this. Okay, let's have a look at another example, which will be example number 6. We are required to sketch roughly the curve described by the polar equation 3 minus 3 cos theta. So the first thing we need to realize is what is the value of A and B. So when I look at that, I should be able to see that my A is 3. And when I look at that, I should see that my B is 3. So I need to find A divided by B, which you will see that it is 3 over 3, which is 1. And once we see that A over B is 1, we should be reminded that whatever we are looking at is called a cardioid. So once we see cardioid, we should know that we are speaking of a heart. So whatever I'm expecting it to be heart-like in its nature. Okay. But then I need to remember what kind of graph I'm going to have. So I have a cos. So whenever I see cos, I should remember that cos is associated with x in polar coordinates. A, for example, r cos theta. So that is associated with x, which means here we are dealing with HA. And HA, I've previously told you that it is the horizontal axis. That is what we are dealing with. Okay. So since I know I'm dealing with the horizontal axis, all what I need to look at now, lastly, is the sign in between. So the sign is negative. So since I'm dealing with the horizontal axis and I have a negative, it means we are on the left-hand side. That is where our cardioid is supposed to be protruding towards. So that means I can start our cardioid like that, go, then come back like that. That is how our cardioid look. At times I will draw it to be a bit sharper, at times not, but as long as it looks like it has a heart somewhere. That is how our cardioid looks. Okay. So that point there and this point here, we know they are always equal A. So our A equals 3. So we have a equals 3. Then that point there, we remember that it is given by a plus b, which will be 6. That is what that point will be. Okay, let's try that again. So that point will be at number 6. Facing left because of the negative, which is highlighted in pink. That is how we would draw this cardioid described by the equation r equals 3 minus cos, or 3 minus 3 cos of theta. Next, we'll be looking at example number 7. Example 7 reads, sketch roughly the curve described by the polar equation below. The polar equation which we have is r equals 1 plus sine theta. What we need to realize is that our a equals 1, and since we do not see anything multiplying the sign, we will know that there is a 1, so which means our b will be 1. And guess what? Our a divided by b will be 1 over 1, which equals 1. And guess what? This means we have a cardioid. And by now we should know that whenever you see cardioid, you should be thinking of a heart looking kind of shape. Like that. That is what should come to our mind. And that should make you to smile a bit whenever a divided by b equals 1, because you know how the shape should look. But there's something else which you need to remember, which is that you are dealing with sine now. And remember, when you are dealing with polar coordinates, sine is associated with the y. So as sine is associated with y, which is the vertical axis. Okay, so if you think carefully of what is going on, we know we are dealing with the vertical axis. To figure out if we should go up or down, we look at the sign. The sign is positive. So this means my cardioid should face more up than down. So I'll go and draw it. So our cardioid will be something like this. It will be something like that. And then we'll have that point there. And that point, this will always be given by a, which is 1. A is 1. Then that top point there will always be given a plus b by a plus b, which will be 2. Because a is 1 and also b is 1. Okay. So our a is 1 and our b is 1. So that is how our cardioid is going to look like. For example, number 7. Next, let's have a look at example 8. On this example, we are required to sketch roughly the curve described by the polar equation r equals 4 minus 4 sine theta. So the first thing we need to realize is that our value of a is 4. And also our value of b is 4. Most importantly, we always need to go and find the ratio of a and b, which in this case will be 4 over 4, which will give us 1. And once we see 1, our brain should remind us that we are working with a cardioid. And once it reminds us that we are looking at a cardioid, we should remember what shape you're looking at. So a cardioid is more like a heart. So we're looking at a shape that is something like this. Okay. Then how is this shape going to be plotted? You then need to remember that you're working with sine, and sine has to do with y, and y is just related to the vertical axis. So for our sine, we'll just focus on the vertical axis. Are we looking at the upper vertical axis or part or the below one, that will be determined by the sign here. So our sign is negative. It means our cardioid should be facing down. Okay, so let's go and draw our cardioid. So our cardioid will start off there, go around, and come back there. That is how our cardioid is going to look. Okay. So what we can then do is to quickly find the values. What is the A there? What is the value there? So the A there, if you look carefully, A will be 4. A will be 4 also there. And then this part here will always be given by A plus B, which is 4 plus 4. That will be 8. So that gives us our cardioid for the expression R equals 4 minus 4 sine of theta. I hope this makes sense, and you will be able to do problems which have the A divided by B equaling 1. So very importantly, please make sure that what is going on this page, you are aware of. This is essentially the summary of how we plot our cardioid. Very importantly, the A divided by B must be 1 for us to draw the shape this way. We'll look at another case where A plus or A divided by B is bigger than 1 and A plus B is less than 2 and bigger or equal to 2. For now, this is how we draw a cardioid, which is always given by A divided by B equaling 1. Essentially, as long as A equals B, we have a cardioid. I hope you understand. Cheers.